Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to be looking at the law of sines again, and we're going to be looking at how to find the area of a triangle, and we have one other example of an application in this video. So let's go ahead and get started. So, you can see here that this is obviously an oblique triangle, and in that, we have an angle that is, wider than 90 degrees here. And there's lots of different things that you can see here. So you can see here the letters in red represent the sides, so A, B, and C. And then the Greek letters that are in orange here, they represent the angles. So angle gamma, angle alpha, angle beta. And then over here off to the left, you can see here that we can also calculate the height. So that's the h in the little green dots right there, the green dashes, if you will. Now, you guys are already familiar with the area of a triangle. So area equals 1/2 times base times height. That's basic. You learned that way back in early high school. However, you can use what you know about sines and the law of sines to find the area of a triangle when you don't know the height, if you will. And so if you want to do that, here is the equations for that. It all depends on what you're looking at. So you can also find the area by taking 1/2 times b times c times sine of alpha. So basically what's happening here is that you take the two sides and then you take the angle of the one side you're not using. So since I'm using side B and C, I use angle alpha. All right. And so if I continue with that line of thought, if I use 1/2 times AC sine of beta, you can see here, since I'm using angle A and C, I now use since I'm using sides A and C, I now use angle beta. And then of course the last one will be, if I have AB, so 1/2 A times B, it'll be sine gamma. So since I'm using sides A and B, I now use angle gamma. That's how it works. So any three of these combinations will work, and this will give you the area of an oblique triangle if you're not able to calculate the height for whatever reason. So I want to now show you a practical example. So I'm going to go ahead and draw this for you. This is what it looks like. So it's going to be like this. This is not drawn to scale, obviously. Draw like that, something like this. It's not perfect. And so this is angle B right here. Oh, that's kind of ugly. This is angle B right here. This is angle A. Angle A is going to equal 7.2, by the way. We know that information. And then we got beta up here. I'm going to give that a different color so I don't get confused. Beta up here. I got gamma down here. And of course I got alpha right here. Now beta is going to equal 42 degrees. We know that. That's information that's provided for us. And then of course we have angle C here. Angle C is going to equal, let's see here, 3.4. And this is all the information that we have. So using the following information that we have, we want to find the area of this triangle. So we're not going to try to calculate the height. Instead, we're going to use what we know about the law of sines and finding the area of an oblique triangle to complete this. So here's what we're going to do. This is what we're going to do. We're going to do area equals 1/2. Now, what do we know? We know sine of B. So if we're using sine beta, if we're using sine beta, that means we're going to use angles or sides A and C. That's what we're going to use. So we're going to put 7.2 in parentheses here, and then we're going to put 3.4 in parentheses, and then we're going to put sine. It's going to be kind of small here. 42. Trust me, that's a 42. So that's what we're doing. Since we know the angle of beta, we're going to take the other two sides, A and C, 7.2 and 3.4. We multiply all this, and your answer is going to be about 8.19. About that, if you were to calculate that in the calculator. And so that's how that will work in that particular situation. So without knowing the height, we were able to calculate the area because we knew one of the angles of one of the vertices, one of the vertices. All right. So let's do one more. Now this is going to be a little bit more complicated. This time, what we're trying to do, we're trying to find the height of the triangle. So it's going to be a little bit more complicated, if you will. So this is what we have. We have this triangle like this. And then of course we have our sides here. So we got a B. We don't know what B is. We do know that C equals 145. That comes in handy. And we don't know A. And then we also have our angles. And so we got alpha right here. We don't know alpha. Oh, yeah. Oh, I'm sorry. We do know alpha. Sorry about that. 70 degrees. We know beta. Beta also. We know beta. Beta is going to be 62 degrees. But technically, we don't know gamma yet. Although, if you're paying attention, it won't take a lot of work to find out what that is. So now, what we're trying to do now is we're trying to figure out this height right here. In other words, like for example, maybe there's a plane in the sky or a kite in the sky or something, whatever, and we want to try to figure out what is this distance right here. Now, the first thing we need to do is we need to figure out what gamma is. And that's very, very simple. You just take 180, you subtract 70, you subtract 62, and that'll give you gamma. And so if you just do some basic math here, you're going to find out that gamma equals 48 degrees. That's what gamma equals. So we're going to put a 48 here. I'm going to put it in a different color because I calculated it. It wasn't given to me. So it's not much of a different color, but it is a different color. All right. So we know that that side is 48 degrees. Now we need to find the distance here of angle side B. And so we're going to use what we know about the law of sines to do that. So sine 62. Sine 62. Now why am I using sine 62? Because that is the angle for side B. Sine 62 over B equals, and I can do whatever I want here, but I'm going to take what the computer gave me or what the program gave me. So I'm going to use C here. And so that's going to be sine 48 over 145. Very, very basic calculation here. Now, I'm assuming you know how to do this. First, we multiply both sides by B. And so if I do that, I really would not want to spend all my time solving the whole thing here, but just to make it clear, sine of 62 equals sine of 48 over 145 multiplied by B. And then, of course, you then multiply both sides by the reciprocal of sine 48 over 145B. And so you end up with sine 62 multiplied by 145 over, 145 over sine 48 equals B. And if you plug all that into your calculator, the answer that you will get is 172.3. So in other words, the length of side B is 172.3. So I'm going to go ahead and put that inside my answer here, 172.3. And so now we know two of the sides. We don't need to know all three. Now we can take this information and we can use what we just learned in the previous example to actually calculate the height. Now see if you can watch what I'm doing here. So here's what's happening. I need a little bit more space, so I'm going to move here. So this is what we're going to do. We're going to do sine of 70. Let me draw the triangle again. Let me go back, and I need to copy this. Just take all this right here, and then I'll copy it. And then I'll go to the next slide, and I'll paste it because I need this. Okay, here's my information. Okay, now, here's what we're going to do. We are going to calculate this by just using sine. So, sine of 70. Because that's alpha right here. Sine 70 equals, now, we know the hypotenuse here, right? We know this hypotenuse is 172.3. We want to find the opposite side. That's what we want to find. So, if we use that, opposite over hypotenuse, or hypotenuse over opposite, is that, yeah, opposite over hypotenuse over opposite is how it works out here. And so opposite over hypotenuse. Okay, opposite over hypotenuse, excuse me. All right, so we put the hypotenuse on the bottom. All right, so that's what we do. So the hypotenuse is 172. And so we need to find the opposite on top. That's what we do. It's also called the height. All right, that's why it can be confusing. And so, it's not that complicated. We just multiply both sides by 172.3. And so we get sine of 70 times 172.3 will give me the length of the opposite, also known as the height. Hope you're not confused by that. And if you were to run this in your calculator, you'll find out that the opposite, also known as the height, or height, so you don't get confused there, is 161.9. So here's what happened, because I'm thinking that's a little confusing. We know that sine is opposite over hypotenuse. That's how that works. So we know the hypotenuse is 172.3. We don't care about the adjacent. We wanted to find the opposite here. And so we took that knowledge. Now I'm calling it opposite because that's how it works when you're talking about SOHCAHTOA. But actually, when we find the opposite, we're finding the height of the triangle. So that when you can use an H instead. But when you use an H, we're also using hypotenuse, it gets confusing. So we just call it opposite for now. And so we know that sine 70 is going to be opposite over 172.3, opposite over hypotenuse. Okay, we solve for the O, or the opposite, and then we say the opposite or the height is 161.9. In other words, if you put this right here into your calculator, you're going to get 161.9. That's what's happening there. So I hope that wasn't too confusing. Now let me go back and try to review what we talked about and then conclude the video. So in this video, we talked about using the law of sines to find the area of an oblique triangle and also for other applications. And so if you look closely right here, the key are these three formulas right here, where you take two of the side lengths and you use the other angle, if you will, to find the area of the triangle. So you need to have, a little bit of information here. Now, here was an actual example of what we did. And so you can see here that A and C were given to me. I didn't get B, but I don't need to get B. It's not necessary because that's not my purpose. And so I wanted to find the area of this triangle right here. And so taking my knowledge of how to find the area, well, okay, I know angles A and C, so that means that I'm going to use angle beta for my sine angle, and then I just multiply across, and I got 8.19. Not that deep. And so after that, we had an actual application here of where we were trying to find the height of the triangle using the same ideas. So first, we had to find what gamma was, and that's what we did just using basic subtraction. And then we found the length of the side beta by just using the other information that was available for us. That's what we did. And so again, using the law of sines here, we found the length of that side, 172.3, and then we were able to find the height by just using what we know about sine, how it's opposite over hypotenuse. And so we knew the hypotenuse here, we knew that. We did not know the adjacent, we don't need to know the adjacent. And then we were trying to find the opposite. So we put O here for opposite, we ran everything accordingly, and we got the opposite, or actually in this case, it was the height, which I know was confusing. So I hope this video was useful for you and you were able to understand what we were talking about here. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.